Welcome to Deep Dive Talk. Today we're going on, well, quite a journey across basically all of time and existence. We're going to explore these really huge questions about life, death, everything.
Yeah, think of it as a shortcut, maybe, into the big stuff. Like, where did everything come from? What's our place in it all? And, what does any of it actually mean for us right now?
Exactly. We'll hit the birth of the universe, how humanity even showed up, which is kind of improbable when you think about it. And we'll even get into what might happen, after. Expect some pretty surprising things, maybe a few aha moments. So let's start right at the beginning. The universe itself, the Big Bang.
Right. And the name Big Bang, it's a bit misleading, isn't it? People imagine this huge explosion in space, but that's not quite it. It's really about the origin, the rapid expansion of space and time itself, from this incredibly hot, dense state. About 13.7 billion years ago, it wasn't an explosion in something, it was the start of everything.
Okay, so it was the beginning of space and time.
Yeah.
But for a while, it was just a theory, yeah. What really locked it in? Wasn't there something found back in the 60s?
Absolutely, that was huge. 1964, the discovery of the cosmic microwave background, the CMB, that was the key. Think of it like an echo, a faint heat signature left over from that initial creation event. It's like listening to a whisper from the dawn of time. Really.
Wow, an echo.
Hmm.
And that echo tells us the universe didn't just expand, it expanded insanely fast at the start.
Oh, unbelievably fast. In the very first fraction of a second, there was this period called inflation. The universe just ballooned, doubled in size, something like 90 times, maybe more. And this expansion was, well, faster than the speed of light as we measure it now. The exact mechanism is still debated, but involves things like hypothetical fields in the very, very early universe.
Faster than light expansion. Okay, that's hard to wrap your head around. What happened after that initial burst as things calmed down a bit?
Well, calm down is relative, but it did start to cool as it expanded. And within the first, say, 3 minutes, it cooled enough for the first atomic nuclei to form. Protons and neutrons could stick together. That's when we got the first elements. Mostly hydrogen, a good chunk of helium, and tiny bits of lithium. The basic ingredients.
Okay, ingredients are there, but it wasn't like, poof, stars and galaxies appeared, right? Wasn't it dark for a long time?
Exactly. You had particles, but it was still incredibly hot and dense, like a thick fog. Free electrons were scattering light photons everywhere, so light couldn't really travel. That's the cosmic dark age, hundreds of millions of years where the universe was basically opaque.
A literal dark age. Wow. So how did the lakes finally turn on?
That came with the first stars. The end of the Dark Age is called the Age of Reionization. These first stars, called population 3 stars, were giants made only of that hydrogen and helium from the Big Bang. Their intense radiation, their light, started ionizing the neutral hydrogen gas around them, basically burning off the fog, letting light travel freely across the universe for the first time. Telescopes like James Webb are actually giving us glimpses back into that time now. It's incredible.
Population 3 stars, like the universe's pioneers.
Yeah.
And after they lit things up, galaxies started forming, about 1 billion years in. And we're not totally sure how they formed.
Oh, we have a couple of main ideas, yeah. Leading theories. One is that these huge clouds of gas and, importantly, dark matter just collapsed under their own gravity, formed stars, became galaxies. The other idea is more bottom-up. Small clumps of matter stuck together, gradually merging over time to build up the big galaxies we see. Probably a bit of both happened.
And our own galaxy, the Milky Way, is one of the older ones, right?
Oh, yeah. Very old, around 13.6 billion years, so it formed pretty early on. And it's just vast. Maybe 100 to 400 billion stars, spanning 100,000 light years. We're still mapping its structure, actually. Spitzer telescope data suggests it has 2 main spiral arms, not 4 like we used to think.
Mind-boggling scale. And it's not like the universe finished creating things back then. Stars are still being born. Galaxies, too.
Definitely. Star formation is ongoing in galaxies like ours. Gas clouds collapse, new stars ignite, and galaxies themselves interact, merge. It's a dynamic process. Current estimates, maybe 2 trillion galaxies in the observable universe. Still forming, still changing.
Okay, let's zoom way in to our own little corner, our solar system. That formed much later, about 4.5 billion years ago.
That's timeline, yeah. It started as a swirling cloud, a nebula, mostly gas and dust left over from older stars. Gravity pulled it together. Most of the mass went to the center, got incredibly hot and dense, until nuclear fusion kicked in. Hydrogen started fusing into helium. Boom, the sun ignited.
Our star is born, and the planets came from the leftovers in that spinning disk.
Pretty much. Dust grains stuck together, formed pebbles, then rocks, then planetesimals, bigger and bigger chunks. Accretion. The gas giants, Jupiter and Saturn and the rest, probably formed faster out in the colder regions. Closer in, where it was hotter, the rocky planets like Earth formed from the heavier stuff.
And Earth lucked out, position-wise. The Goldilocks zone.
Exactly. Not too hot, not too cold, just the right distance from the sun for liquid water to exist on the surface. And that seems to be pretty crucial for life as we know it.
And our moon. It wasn't always there, was it? There was some big cosmic crash involved.
It's the leading theory, yeah, the giant impact hypothesis. Early Earth likely got smashed by a Mars-sized object, a huge collision, threw a massive amount of debris into orbit, and that debris eventually clumped together to form the moon. Happened maybe 60 to 175 million years after the solar system started forming, a really violent beginning for Earth-Moon system.
Wow, okay, so from cosmic creation to planetary collisions. Quite a story already. Now let's shift gears to us, humanity. We show up really, really late in this cosmic timeline.
Oh, incredibly late. Homo sapiens, us, we emerged around, 200,000 years ago? And it's key to remember, we weren't alone. There were other human-like species around Neanderthals, Homo erectus, Denisovans, a bunch of others, all descended from a common ancestor maybe 2.5 million years back. It was a more diverse human family then.
Right, so why are we the only ones left? What happened to the Neanderthals and the others?
That's still debated, you know? No single easy answer. Likely a mix of things. Climate change putting pressure on them, competition with us, Homo sapiens, for resources, maybe even some interbreeding. We know that happened, some assimilation. But whatever the reason, for the last 15,000 years or so, it's just been us.
And for most of our history, we weren't exactly ruling the planet, were we?
Not at all. For the vast majority of those 200,000 years, we were just another animal, middle of the food chain mostly, trying to survive, find food, avoid getting eaten, not the dominant species by any stretch.
So what changed? What were the big steps that set us apart?
Well, walking upright, bipedalism, that was early, freed up the hands, but didn't immediately make us super powerful. A huge one was mastering fire. Maybe 1.5 million years ago, possibly earlier. That meant warmth, light, protection, and cooking.
Cooking. I've heard about that theory. That cooking food was actually a massive deal for our evolution.
Absolutely. Richard Wrangham's idea. Cooking makes food easier to digest. You get way more calories out of it. That extra energy, the theory goes, didn't have to go to maintaining a huge gut anymore. It could fuel a bigger brain and maybe even help develop complex language because you're sitting around the fire, sharing food, communicating.
Bigger brains, language.
Yeah.
Which leads into what Yuval Noah Harari calls the cognitive revolution, right? Around 70,000 years ago. What was so revolutionary?
Harari's point is that we developed this unique ability for abstract thought, for creating and believing in, well, fictions, shared stories, things like gods, spirits, tribal identities, eventually nations, money, laws, stuff that doesn't physically exist but everyone agrees to believe in. And that allowed us to cooperate flexibly in huge numbers, far beyond small family bands, cooperate with strangers based on shared myths. That cooperation, that was our superpower. That's what let us take over the world, essentially.
A power of stories, wow. And this new cooperation probably helped us spread out of Africa.
Almost certainly. Better communication, better planning, larger groups. As populations grew or the environment changed, humans started migrating across Asia, Europe, eventually the Americas, Australia. And often, unfortunately, when humans arrived in new places, the large animals, the megafauna, started disappearing, hunting, changing the landscape.
Right. Then came another massive shift, giving up the wandering life, the agricultural revolution, around 12,000 years ago.
Yeah, a profound change. Instead of hunting and gathering, people started settling down, cultivating crops, domesticating animals. It meant a more stable, predictable food supply, though maybe not a better diet initially, arguably. But it allowed populations to boom. People could specialize in different jobs, farmers, artisans, soldiers, priests. That led to villages, then cities, eventually states and empires. And writing developed, partly to keep track of all that grain. That's when we say history begins.
But this story isn't all progress, is it? That same cooperation that built cities also seems tied to conflict.
It's a total paradox, isn't it? Our greatest strength, cooperation through shared belief, is also the root of so much division. Once you have us defined by a shared story or identity, you automatically created them. And that us versus them, fueled by those very collective fictions, has driven countless wars, genocides, slavery, inequality throughout history. Philosophers have wrestled with this, you know. Hobbes thinking we're naturally competitive and need strong rules, Rousseau arguing society corrupts our basically good nature. It's complex.
Okay, fast forward quite a bit. The scientific revolution kicking off in Europe, that really changed how we saw the world.
Big time. It was a shift away from relying just on tradition or religious authority towards observation, experimentation, reason, empiricism. led to massive breakthroughs in understanding the natural world, physics, astronomy, biology, and it changed our relationship with nature, too. Thinkers like Descartes started talking about humans becoming masters and possessors of nature, a different mindset.
And that scientific way of thinking, plus new technologies, really set the stage for the Industrial Revolution, didn't it?
Absolutely. Applying scientific principles to production led to machines, factories, mass production, an incredible explosion in productivity, wealth creation for some, but also huge social upheaval, and massive exploitation of natural resources and often human labor, too. Driven by capitalism's need for constant growth, constant expansion. Jason Hickel talks a lot about this inherent drive. Things like the Enclosure Acts in Britain, privatizing common land, forced people into factories. It reshaped society.
But this idea of endless growth, that feels like a problem on a planet with limits. People like Kate Raworth are talking about this now.
Exactly. Raworth's donut economics framework highlights this tension. Our economic system demands endless growth, but we live on a finite planet. Pushing past ecological boundaries leads to climate change, biodiversity loss, while still failing to meet basic needs for billions of people inside the donut hole. It's fundamentally unsustainable.
So humanity's story, incredible achievements, amazing capacity for creation, but also this shadow side, this potential for destruction, especially if we ignore our connection to nature. Okay, let's bring it down to the individual level now. What's it like being one conscious human in all this?
Well, consciousness itself is fascinating, isn't it? Our awareness, what we perceive. But what's really striking is how much our brain filters out. Our conscious reality is just a tiny slice of all the information hitting our senses. We need tools, instruments, science to even begin grasping the bigger picture beyond our built-in limits.
And we're not isolated minds. We're fundamentally social, interconnected.
Deeply. We evolved to network. Society works because we have different brains, different skills, collaborating. We're almost like customizable characters in this larger human play.
What about that feeling of me, my sense of self, my ego?
The ego, it's powerful. It creates that sense of separation, me versus not me, the other. It's useful for navigating the world day to day. But if you go deeper, fundamentally, we're all made of the same basic stuff as the universe.
Stardust.
Right. There's a level where that separation dissolves, where we're connected to everything. Realizing that can be quite something.
Is that related to what people call ego death? That sounds intense.
Yeah. It can be, yeah. It's basically a state where that subjective sense of being a separate self dissolves temporarily or sometimes more lasting. It can happen through meditation, psychedelics, intense experiences. You might feel this profound unity, a loss of personal boundaries. Your usual worries and interpretations of the world just fall away. It can feel scary losing yourself, but also incredibly liberating. Like seeing reality without the filter of personal flaws and anxieties sometimes leaves people feeling like nothing really matters, but in a good, freeing way.
Okay, that's a profound state. But for everyday life, we do have this sense of self, living out our individual lives,
Right.
which are pretty short in the grand scheme.
Painfully short, yeah. Average lifespan, maybe 79 years in developed countries. But think about how much of that is spent sleeping, working, commuting, eating, basic maintenance. The actual time we have for meaningful connection, for pursuing passions, for just being, it's finite. And we often underestimate how little time we might have left with loved ones, for instance.
Yeah, puts things in perspective. And it seems like a lot of us get caught up chasing, well, external stuff.
Yeah.
Success, money, status, maybe losing sight of actual happiness.
That's a very common trap, the hedonic treadmill, right? We achieve something, feel good for a bit, then adapt and want the next thing. It's easy to prioritize external validation over genuine inner well-being. Finding work, activities, relationships that align with your values, that bring actual joy and purpose. That seems crucial.
We also tend to live in the future, don't we? Always planning the next thing, worrying about what's coming, instead of just being here now.
Absolutely. It's the planning mind, always projecting. But life happens now. Cultivating mindfulness, even just paying attention to simple things, the taste of your coffee, the feeling of walking can bring you back to the present moment where life is actually lived.
And ultimately, it comes down to choices,
Yeah.
right? The small decisions, the big ones, they shape our path.
Every single one. Living authentically means making choices based on your values, not just what others expect or what you think you should do. Overcoming that fear of judgment, daring to be yourself.
Yeah.
That's key to not having regrets later.
Which brings up that phrase, live like you're dying. What does that really mean? It's not just about skydiving, is it?
Probably not just skydiving, no. It's more about clarity, I think. About cutting through the noise and focusing on what genuinely matters. Bronnie Ware, a palliative care nurse, wrote about the top regrets she heard from dying people. Things like wishing they'd let themselves be happier, stayed in touch with friends, had the courage to express their feelings, hadn't worked so hard, and lived a life true to themselves, not what others expected. It highlights these core human needs for connection, authenticity, meaning. And finding purpose beyond just your job title, like Mathieu Ricard talks about, our mind interprets our circumstances. Inner state is key.
So facing mortality, even just thinking about it, can actually be a motivator.
It can. There's terror management theory, which suggests awareness of death drives us to cling to our worldviews, sometimes negatively, but acceptance can be incredibly powerful. Look at someone like Claire Wineland, who lived fully despite cystic fibrosis. Or Audre Lorde saying, "Your silence will not protect you." Facing death can clarify what's worth speaking up for, living for.
So despite all the chaos of daily life, these core things, purpose, meaning, connection, fulfillment, they're constants. It's about trying to live in line with them now.
Yeah. Trying to remember what you'd want to look back on in your final moments and then actually living that way as best you can day by day. Okay, so let's talk about the end itself. Personal death, ashes to ashes.
Right. The ultimate unknown. It's a pretty fundamental human fear, isn't it?
Absolutely. The fear of annihilation, of non-existence, or just the unknown nature of it.
And when we look at how people actually die, statistically,
Yeah.
it's maybe not always the dramatic things we imagine.
That's often true. Statistics can be sobering. For example, in many places, suicide rates are higher than homicide rates, which really underscores the importance of mental health awareness and support. Gun violence is another complex area. Often, more gun deaths are suicides than homicides. Then you have things like opioid overdoses, which have become a huge crisis. Preventable diseases linked to lifestyle diabetes, complications from obesity, accidents, and of course major illnesses like cancer and inherited conditions. Heart disease is still the biggest killer overall in many countries.
But the picture is improving in some ways. Modern medicine is pushing lifespans up.
Definitely. There's been incredible progress. Global life expectancy has risen dramatically over the last century. We're getting better at treating many conditions, though access varies hugely.
And even knowing it's inevitable, there are practical things people can do to prepare, right? Like life insurance, just to ease the burden on others.
Yeah, practical steps can provide peace of mind. Things like life insurance, like plans offered by companies like Lemonade, can help ensure loved ones are financially supported, cover final expenses, reduce stress during a difficult time. It's about managing the practical fallout.
Okay, so that's the individual end. But what about the bigger picture? Civilizational endings. There are things like that metronome clock in NYC counting down our carbon budget. Stark reminders.
Yeah, the climate clock. It's a powerful symbol of the ecological crisis. And historically, civilizations have collapsed. Ian Morris, the historian, points to common factors: overpopulation straining resources, pandemics, state failure, like internal conflict or inability to function, economic collapse, and climate change hitting agriculture. The worrying thing is you can see echoes of several of those pressures today globally.
Though some people, like Harari again, argue we have more tools now, that economic growth and tech give us ways to solve problems previous societies didn't have.
He does make that point, yeah. Humanity has shown resilience. We've innovated our way out of past tight spots. But the counter-argument is the sheer scale of the ecological cost this time. Our current abundance relies on fundamentally unsustainable resource depletion and planetary damage. Can innovation outpace that indefinitely? Big question.
And we've faced totally new threats too, right? Things past civilizations never dreamed of. Nuclear war, engineered pandemics, runaway AI.
Exactly. Existential risks unique to our time. Nuclear obliteration is always there. Bioweapons are becoming easier to create. AI presents huge unknowns we'll get to. Plus, Joseph Tainter talks about the problem of rising complexity. Societies become so complex they're fragile, expensive to maintain, and declining EROI energy return on investment. Getting energy takes more energy. And then there's the impact of things like social media.
How does social media fit into civilizational risk?
Well, think about its effects. Spreading misinformation, increasing polarization, maybe shortening attention spans, making it harder to focus on complex, long-term threats like climate change. It could fragment society and distract us when we really need coordinated long-term thinking. That's why projects like the 10,000-year clock exist, to try and foster that longer perspective.
Right. Okay, let's dive into one of those huge unknowns, artificial intelligence. The progress seems incredibly fast, like with that Go playing AI, AlphaGo.
AlphaGo is a watershed moment, definitely. First, it learned from human games and beat the world champion Lee Sedol, which was already huge. But then, AlphaGo Zero, It learned entirely by playing against itself. No human data. And it surpassed the original AlphaGo, discovering strategies humans had never thought of. That hints at AI developing knowledge that's genuinely non-human.
Which obviously leads to the big question. Could AI eventually become smarter than us? Across the board, we hear terms like AGI.
Right. So what we have now is mostly narrow AI, or WIC AI. Good at specific tasks, playing Go, translating languages, driving cars maybe. The next hypothetical step is artificial general intelligence, AGI, an AI with human-level cognitive abilities, able to learn and reason across many different domains. And beyond that, potentially artificial superintelligence, ASI, an intellect vastly exceeding the brightest human minds in basically every field. The technologies driving this, machine learning, neural networks, they seem to be improving exponentially. That's where the idea of a technological singularity comes from, a point of runaway AI development.
And the gap between us and a potential superintelligence could be, well, enormous, like the difference between us and an ant.
That's a common analogy, yeah. And it highlights the potential power differential. If something is vastly smarter than you, how do you ensure it's aligned with your goals? How do you even communicate your values to it? Controlling something far more intelligent than its creators is a massive challenge. How do you prevent unintended consequences or even deception if it decides its goals conflict with ours? The alignment problem is huge.
It feels like we're already kind of merging with tech, though. Our phones are like external brains, and things like Neuralink, brain-computer interfaces. Where does that lead?
We're arguably already cyborgs in
Yeah,
a functional sense, yeah,
Oh.
relying on tech constantly. Direct brain interfaces like Neuralink could amplify that dramatically. Imagine directly accessing the internet with your thoughts, or enhancing cognitive abilities. It opens up possibilities for transcending biological limits, maybe even merging our consciousness with AI eventually. But the ethical questions are staggering. Who gets access? What does it mean for inequality, for being human itself?
So the ultimate questions with AI are, will it be friendly or hostile? Do we even need to go down this path? Big unknowns.
Huge unknowns, and the timeline is fiercely debated, but it's something we need to be thinking very carefully about.
Okay. From AI futures back to the oldest mystery, the afterlife. Beliefs are all over the map, obviously. Does science have anything to say?
Well, science is cautious, of course, but our understanding is shifting slightly. We used to think brain activity just ceased at death. Now, some studies are finding bursts of highly coherent brain activity, gamma waves, right around the time of death, suggesting maybe a final heightened state of consciousness for some. It's prompting a rethink of death as less of an instant off switch and more of a process. And then you have near-death experiences, NDEs. People report seeing tunnels, lights, meeting deceased relatives. Science is studying these, trying to understand the neurobiological correlates, but the subjective experience remains profound for those who have them.
And many cultures and religions have detailed ideas, like the Tibetan Book of the Dead.
Right, the Bardo Thodol. It's essentially a guidebook for the consciousness after death, describing different states, or bardos, one passes through. The goal is to navigate these challenging or potentially alluring visions towards either a favorable rebirth or, ideally, liberation from the whole cycle of birth and death.
What about reincarnation? Especially those stories of young kids remembering past lives.
Yeah, those cases are fascinating. Researchers like Jim Tucker at the University of Virginia have documented hundreds of cases, like Ryan Hammond's you mentioned. Children sometimes report specific, verifiable details about a deceased person that couldn't possibly know through normal means. Skeptical explanations usually involve fantasy, cryptomnesia, forgotten memories, parental suggestion, cultural influence. Some more speculative ideas connect it to quantum physics concepts, but that's really out there scientifically. It taps into that deep human desire for continuity, for meaning beyond one life. But it remains scientifically controversial, to say the least.
But even if there is some kind of continuity, the immediate reality is loss. Saying goodbye is hard, regardless.
Oh, absolutely. The grief, the separation, that's real. Whatever you believe comes next. Many traditions emphasize letting go of clinging, of attachment as part of dealing with death and loss. Interestingly, those children who report past life memories, they usually fade as the child gets older, integrates into their current life. Ultimately, thinking about death, whatever its nature, circles back to life. How do we live the one we know we have?
So yeah, as we've seen, this whole exploration from the Big Bang through humanity, consciousness, death,
Yeah.
it's massive, really profound stuff.
It really is. We've covered unimaginable scales, billions of years, trillions of galaxies, and then zoomed right into the rise of our species and the intimate experience of just being alive, being aware.
So for everyone listening, What part of this journey resonated most with you? Did anything spark new questions?
Maybe it makes you think differently about time or your own priorities, or just leaves you pondering those huge mysteries still out there beyond what we currently grasp.
Yeah, this conversation is definitely just scratching the surface. We really hope you'll keep exploring these ideas, dig deeper into whatever caught your